Hello everyone, welcome back to my YouTube channel. I'm Arya Bayu and my partner.
And me, Tirta Jayanti.
In this video, we will learn about mathematical logic. Hope you guys enjoy. For the first, I will explain about statement and its truth value. A statement is a declarative sentence which is either true or false but not both simultaneously. And a sentence is not a statement if we cannot determine the sentence is true or false or contains a relative meaning. For the example, 3 is an odd number. That is true statement. 2 plus 3 is 6. That is false statement. And last, Jakarta and Bandung are close. That is not a statement because close is relative. The truth value of a true statement is defined to be T, and the truth value of a false statement is defined to be F. Statements are denoted by the letter P, Q, R, and blank blank blank. There are two types of mathematical statements, namely closed statements and open statements. A closed statement is a statement whose truth value is certain, while an open statement is a statement whose truth value is uncertain. For more detail, consider the example below. 6 multiplied by 5 equals 30. That is true closed statement. 6 plus 5 is 10. That is false closed statement. And x multiplied by 5 is 20. This is an open sentence as its truth depends on value of x. If x is 4, it is true, and if x is not 4, it is false. And next I will explain about logical connectives and truth table. The first is conjunction. For the example, we have two statements. P, today is a pleasant day. And Q, I want to go for shopping. The conjunction of above two statements is P conjunction Q. In essence, today is pleasant day and I want to go for shopping. A conjunction is true if and only if both P and Q are true. Truth table for conjunction of P and Q is as shown below. And next is disjunction. For the example, the first statement, Rahul will pass or fail in the exam. And the second statement, candidate must be graduate or postgraduate. In the first statement, R indicates that only one of the two possibilities exists, but not both, which is called exclusive sense of R. In second statement, R indicates that first or second or both the possibilities may exist, which is called inclusive sense of R. Truth table for conjunction of P and Q is as shown below. And next is negation. For example, we have statement P. Mango is a fruit. The negation of P is mango is not a fruit. Truth table for negation is as shown below. For the not, if a statement is true, its negation is false and vice versa. And next is implication or conditional. For example, statement P, I travel by train. And statement Q, my journey will be cheaper. Here the conditional statement is P implication Q. In essence, if I travel by train, then my journey will be cheaper. Conditional statement is false if and only if antecedent is true and consequence is false. Truth table for conditional is as shown below. And next is converse, inverse, and contrapositive statement. If P implication Q is given, then its converse is Q implication P. Inverse is negation P implication negation Q. Contrapositive is negation Q implication negation P. For the example, let P Smita is intelligent and Q Smita will join medical. The converse statement is Q implication P. In essence, if Smita joins medical, then she is intelligent. And inverse statement is if Smita is not intelligent, then she will not join medical. And the contrapositive statement, in essence, if Smita does not join medical, then she is not intelligent.
And for the next, I will explain you about if and only if or double implication, or we can also call P conditional. For example, let P as a price increases and Q as demand falls. Here the big conditional statement is B implies Q as price increases if and only if demand falls. A big conditional statement is true if and only if both the implicants have same truth value. The truth table you can see in this slide. Next, we will learn about statement pattern and logical equivalence. First, statement pattern. Let P, Q, and R be simple statements. A compound statement obtained from the simple statements and by using one or more connectivities like conjunction symbol, disjunction symbol, negation, implies and be implies is called a statement pattern. Following points must be noted while preparing truth tables of the statement patterns. First, parentheses must be introduced wherever necessary. For example, a negation of P, conjunction Q, and negation P, conjunction Q are not the same. Second, if a statement pattern consists of N statements and M connectives, then truth table consists of 2 to the power of N rows and M plus N columns. Logical equivalence. Two logical statements are said to be equivalent if and only if the truth values in their respective columns in the joint truth table are identical. If S1 and S2 are logically equivalent statement patterns, we write S1 minus S2. As for the logical equivalence operation properties, first, negation of P disjunction Q equivalent to negation P and negation Q. It is used De Morgan's first law. Second, negation of P conjunction Q equivalent to negation P or negation Q. It used De Morgan's second law. And third, P implies Q equivalent to negation P disjunction Q. And fourth, B implies Q equivalent to P implies Q conjunction Q implies P. Tautology, contradiction, and contingency. Tautology. A statement pattern having truth value always T. Irrespective of the truth values of its component, statement is called tautology. For example, consider P implies Q, B implies Q, B implies P. You can pay attention to this table. In this truth table, all the entries in the last column are T. So, the given statement pattern is a tautology. Next is contradiction. A statement pattern having truth value always F or false, irrespective of the truth values of its component statement, is called a contradiction. You can pay attention to this truth table. In the above truth table, all the entries in the last column are false or F. So, the given statement pattern is a contradiction. Next, contingency. A statement pattern which is neither a tautology nor a contradiction is called contingency. For example, consider P implies Q, conjunction negation of P implies negation Q. You can see in this table. In the above truth table, the entries in the last column are a combination of true and false. So, the given statement pattern is neither a tautology nor a contradiction, it is a contingency. Next, we will learn about quantifiers and quantified statement. Quantifiers are the symbol used to denote a group of words or a phrase. Generally, two types of quantifiers are used. They are as follows. First, universal quantifier. The symbol every stands for all values of and is known as universal quantifier. For example, consider A equal to 1, 2, 3 and let P every x element A and x less than 4. The statement P uses the quantifier for all. Next, existential quantifier. The symbol every stands for all values of and is known as universal quantifier. For example, consider A equals to 1, 2, 3, let P every x element A and x less than 4 here. The statement P uses the quantifier for all. Quantified statement. The statement containing quantifiers is known as quantified statement. Generally, an open sentence with a quantifier becomes a statement and it's called quantified statement. For example, use quantifiers to convert open sentence x plus 2 less than 4 into a statement. Solutions: x is x, element n, such that x plus 2 less than 4 is a true statement, since x equals to 1, element n satisfies x plus 2 less than 4.
Okay, that's enough for this video. Don't forget to like, comment, and subscribe. And see you in the next video.